This video is going to talk about vectors. So we use vectors a lot in physics. Vectors are a way of being able to understand quantities of ideas that we're talking about, and it's a way of being able to also visually understand what's going on. So a vector is any quantity, anything that has two aspects to it. Magnitude, which is how much of the quantity we have, and direction, so magnitude and direction. So the way that we symbolize it, there are three different ways, is that we can talk about it either as a numerical value, in which the number will tell you how much, and the sign will tell you which way. So positive 8 meters tells me that I'm going to be moving 8 meters in the positive direction. And I can show this with an arrow. And the arrow shows the direction of motion, in this case, and the length of it is proportional to the magnitude. It doesn't have to be an absolute thing. It's just if it's larger, you draw it larger, and if it's smaller, you draw it smaller. Now, for our intents and purposes, a positive displacement will either be to the right or it will be up. Those are the general conventions. Negative 4 meters would then be half the length. This arrow is about half the length of this arrow, and also pointed in the opposite direction. So in this case, it's pointed to the left instead of to the right, or down instead of up. So again, the usual convention is that positive is usually right or up, and negative is left or down. So it's mirroring what's happening on an x-axis and a y-axis. As you move to the right on the x-axis or up on the y-axis, your numbers usually get more positive, and as you move left or down, your numbers get more negative. In this course, we're only going to be adding vectors and working with vectors that are in the same axis. So, for example, this vector addition, I have vectors that are going in the x-axis direction or the y-axis direction only. If you take another course in physics later on, you will start to deal with vectors that are moving in lots of different directions and adding them together. So the easiest way to add up vectors, if they're moving in the same direction or the arrows are going in the same direction, you simply add up the numbers. It's as if I'm saying move 8 meters right and then move another 4 meters to the right. In total, you will have moved 12 meters to the right. So the length of this arrow is going to be about the length of these two arrows combined, and it's pointed in the same direction as this. So I could write this as positive 8 meters plus positive 4 meters equals positive 12 meters. If I'm adding vectors that are in opposite directions, then you're going to be adding them as well, but one of them will have a negative number. So this here has 8 meters in the positive direction, plus negative 4 meters in the left direction. So it's as if I'm saying move 8 meters to the right and then go back 4 meters to the left. I will have, in my net displacement, moved a total of 4 meters from my starting point. And the same holds true when you're looking at vector addition in the y direction, if there's no difference. So many of our values, displacement, velocity, acceleration, force, energy, power, all of these things are not only going to tell you how much of that number is, like how fast I'm going, how much energy I'm adding to something, but also which way that I'm adding that amount to. So again, vector quantities must have a number and a sign attached to it to acknowledge the fact that they are vector quantities. And anytime I have vector quantities that are in the same axes, I can add them and come up with, rather than thinking of two vectors here, just the net effect of one vector going in the right direction, in the positive direction. So we call this a net vector or resultant vector.